So Happy New Year, everyone. I hope you had a nice break. I'm taking it that some of you must have got some eyepieces or maybe some telescopes over Christmas, given the crappy weather we had. So that's the only explanation I can think of. Glad you could make it out tonight. I know the driving wasn't all that great. We got a couple of interesting presenters. Next slide, please. And by the way, we had to make a few improvisations here. You'll notice with the projector. So let's see how it goes. Usual program. We got Gary's going to talk about Ottawa skies, is what's up in the January 2015 sky, followed by Al Scott with 10-minute astronomy news. Then what's up is a subject is Rick Wagner. He's going to talk about polar alignment, something we all struggled with in our earlier days of working with our telescopes. For some of you that are new to it, I think you'll find Rick pretty thorough, and he always researches his material well. Only a couple of months ago, you saw a presentation from Rick that was thoroughly researched. I'm actually hoping in that presentation that some audience members can chime in and offer their own insights as well. Have a break, and then after the break, we're going to talk about a valuable center resource, the Fred Lossing Observatory, that's available to members. Gordon's who's a frequent user, is going to talk about the observatory and what it has to offer, and some thoughts on the future. What we're headed with that as well. So if you're a new member, or if you haven't been out to the observatory, I'm sure you'll enjoy his presentation. Some astounding astrophotography by Tony Peterson. Tony is here, and he's going to share his sort of a retrospective on 2014 and some of his best work. I've seen his images. Again, we're in for a treat. Then of course the regular observer images, followed by just a couple of announcements, and it won't be rushed tonight. I promise you that. All right. So I want to start off in a sort of a slow, relaxed mode here. Okay. A couple of announcements here. So Chris, as we're preparing these slides here, Chris pointed out to me something. As you know, every month I'd like to show this, new members here. And this month we've got, or actually in the month of December, after the December 5th meeting, there was a bunch of people who signed up. 3, 6, 9, 12, 12 members signed up after the December 5th meeting. So quite a year for membership, altogether 74 members. John, Eric, Calvin, the Garvey family. Awesome. Are you here tonight, the Garvey family? Okay, well, if you're watching from home, welcome. Tanner, Monica, Stephanie, Brandon, and Larry. I know you're here, Larry. Everyone, thank you. I hope you enjoy the air, and hope you can give lots of feedback on how we can make it better and more enjoyable for you. So, welcome. Oh, I wanted to mention something, because Chris and myself always talk about this as well, is that when you sign up as a member, there is a box you need to tick off which says you wish to be on the email distribution list. Okay, so if you're a new member, any of these 74 new members here, and you haven't, if you didn't receive the email from me last night, okay, which went out to all our ASC members, okay, about talking about the agenda for today's meeting, and you wish to, go see Chris Tarrant. And if you're not here, if you're watching through the internet and you want to be on that, send an email to me, or you can also send one directly to Chris Tarrant as well. Okay, and we'll put you on the list. But I think it's a great way of staying communicated, and you can not only receive emails, but you can send emails as well. Next slide, please. Okay, in the news, members in the news. So this is something that, actually this is a former member, but somebody that has really done some amazing stuff. So Sanjeev Silverazu has opened up a gallery in Elmont. And he's a artist who specializes in astrophotography. And he's really he's really takes it to a different level. I mean, his enjoyment of the night sky and the beauty of it and so forth. If you're in the Elmont area, go visit him, because I'm sure he'd love to, and I'm sure he'd love to share with you his work and talk astronomy as well. He had an article here on the front page of and I'm forgetting. The Hum news magazine. Did anybody see that recently?
There's one in the door prize pile down there.
Okay, it sounds like there's some in the door prize pile. So congratulations, Sanjeev, and we need to have you come out to one of the meetings here and maybe share with us what you're up to. Okay, next slide. I think that's it for the members of the news. It's pretty light. So Gary, I didn't see you here. I'm hoping you're here.
A bit late.
He's running a bit late?
He will be here.
Okay, so we're going to flip things around. So the roads were obviously awful here. So we are going to go to our break. No, we should all do that when Gary walks into him. I'm sorry, Gary. We're going to go to Al Scott, who's going to talk about what's up in the astronomy news. All right, in this 10-minute astronomy news segment. There you go, Al.
Okay.
Is the volume good enough now?
You can hear? Good. Okay. So, a little bit of a deeper take on the news today in terms of some things that I was reviewing in astronomy news. I noticed there was a bit of a theme going on. There's a lot of interesting stuff about galaxy formation going on in the news. And so I've got a few different takes on galaxy formation and new discoveries in our understanding of how galaxies form. Now this first one is a simulation. It's a supercomputer project headed at Austin, Texas Advanced Computing Center. A multi-institution collaboration, including the University of Toronto in Canada, has produced a new set of supercomputer galaxy simulations called FIRE, or Feedback in Realistic Environments. It focused the computing power of some modern multiprocessor high-power parallel processor computers on smaller scales, and they've been able to throw a lot more physics into the models than they have in the past. Scales of only a few light years across, and simulating galaxy-size evolutions. They start with clouds of gas in the interstellar voids, clouds of neutral hydrogen molecules mainly, which cool over time, become more dense, and form stars. Now, astronomers, physicists, astrophysicists, astronomers feel they understand how these clouds cool to form stars. But what they don't understand is why a lot of the galaxies we see today still have a lot of these clouds remaining, and only a small fraction of the gas mass has been converted into stars. What stops the process of star formation in galaxies? It's not really, there's a lot of different theories as to why there's still gas remaining in some of these spiral galaxies. And so the simulations that were done here have enough physics. They've shown that feedback from stars, the collective effects of supernova radiation, heating, turbulence, and stellar winds can regulate the growth of galaxies, and explains why the galaxies have turned so little of their available supply of gas into stars. Previous simulations didn't have all of the physics in it, and the astronomers needed to add fudge factors for a lot of the various parameters to produce galaxies that were relatively realistic. In these simulations, astronomers just put the physics in, ran the simulations, and came out with galaxies like this one that looked like real galaxies for the first time. So this is a really good first step to understanding or progressing our understanding of how galaxies form. The second news item is observationally based. This is actually an artist's impression of some data. Astronomers have discovered that modest black holes can also shut down star formation in moderate-sized galaxies. And we're talking about moderate black holes by producing turbulence in the dense gas clouds near the core of the galaxy. High-energy jets powered by supermassive black holes we know can blast away the gas in a galaxy, resulting in these so-called red and dead galaxies, where you have a lot of red stars with no gas left in them. A lot of these are ellipticals as well. Astronomers have now used the ALMA Atacama Large Millimeter Array to observe dust and gas at the center of NGC 1266, which is a nearby lenticular galaxy with a relatively modest central black hole. These observations indicate a perfect storm of turbulence is squelching star formation in a region that would otherwise be an ideal star formation factory. The turbulence is stirred up by jets from the galaxy's central black hole slamming into an incredibly dense envelope of gas. This dense region blocks nearly 98% of the material propelled by the jets from escaping the galactic center. This energetic collision produces powerful turbulence in the surrounding gas, disrupting the critical collapse stage that would otherwise form stars hundreds of times more rapidly than otherwise. Previous observations of this particular galaxy, this is an artist's impression, revealed a broad outflow of gas from the galactic center traveling up to 400 kilometers per second. This outflow is as forceful as the simultaneous supernova explosions of 10,000 stars at the core of this galaxy. But they're not powerful enough to actually give the gas escape velocities. The gas is collapsing back into the core. And this dense cloud in the center of this particular galaxy contains about 400 million solar masses of gas, about 100 times more than what you'd find in a typical star-forming cloud in the Milky Way. So an interesting observation in that modest-sized black holes can also throttle formation in modest-sized galaxies. And this has been an unsolved problem in astrophysics for some time as to why these smaller galaxies stop forming stars. We know the larger galaxies, they blow away all their gas with their huge quasar-like black holes in the center. The final item I want to talk to you is an actual observation as well. French astronomers have used a radio telescope in France to discover that dense gas is being blasted out of a compact galaxy. This is called SDSS J0905 plus 57. Very imaginative name. The gas is leaving the galaxy at speeds of up to 2 million miles an hour. The gas is being driven to distances of tens of thousands of light years by the intense pressure exerted on it by the radiation of just the stars that are forming rapidly at the galaxy's center. This is having a major impact, of course, on the evolution of this galaxy. These observations were done by observing the molecule carbon monoxide, which traces the neutral gas in the intergalactic medium. They then infer the amount of hydrogen gas. Hydrogen is more difficult to observe than carbon monoxide due to the wavelength of its emission spectrum. Stars are born from these clouds of hydrogen, so by removing the gas, the galaxy rapidly shuts down its star formation. There's enough gas in this particular outflowing material to form the equivalent of about 1 billion suns. Outflows of warm ionized gas from galaxies are well known, but this particular observation of large amounts of cold, dense gas being violently removed from the central regions of the galaxy and fired into space is a new discovery. So previously it wasn't known that stars in a galaxy in a high star-forming region could do this. As we said, mostly it's high energy black holes that are known to do this, or quasar-type active galactic nuclei. This result, along with the other ones, provide important new insights into how the growth of stars is regulated in galaxies. Thank you.
Thank you, Al. Gary, are you here yet? Okay, he's still making his way on the roads. Before we go to the next speaker, I wanted to actually say something here. I'm going to put something on the spot. Matthew Farkas. So I learned, yeah, he just goes like this. Matthew, I just learned, he's an Ottawa Center member. He's been coming to these meetings for a long time here. I learned just before the holidays that he's just finishing up his schooling in theoretical physics.
No, aerospace engineering.
Okay. Oh, right. Aerospace engineering, and he had put in an application to Google a couple of a while back, and Google phoned him up. He had an interview at the Googleplex, and lots of intense interviews, and they made him an offer. And he's going to be resettling. So congratulations. I know it seems strange, Matthew, but I feel kind of proud, actually, even though I'm not your parent. So, and a bit jealous too. So good for you. So, all right, let's move to Rick Wagner and Rick.
Nope, I'm here.
Oh, Gary is here. All right, so actually, Gary, you only have 30 seconds to run through your slides. So.
Being past president, you don't have the cloud anymore.
That's right. All right, so thanks, Gary. Over to you.
Getting here without a speeding ticket. Well, Orion is well and bright in South Mountain. Unfortunately, it's cloudy here. Welcome to Ottawa Skies for January 2015. Happy New Year, everybody. I hope you had a great holiday. Any new instruments, telescopes, binoculars, eyepieces? Something great. Soup. Okay, first slide, please. Well, the highly anticipated comet Lovejoy is in the sky. Who has seen Lovejoy up to now? Great. It's naked eye in the country. I just saw walking out of the car tonight when I got home. It's just under fifth magnitude now. It's getting pretty bright. The moon is finally out of the sky, so that's really helping things. Except for the cold weather. We're going to have to settle with that for a little while longer. But if you can't, get out there, enjoy it, observe it, photograph it, sketch it if you can. Probably our president has sketched it too. Next slide, please. So here's the path of the comet moving up through eventually through Taurus. So it did come close to the Earth on the 7th. So it will be getting a little fainter, but only by about the end of the month, only 5.6 rather than 4.8 now. So it won't disappear, but it's receding away from Earth, but getting closer to the sun. So that could be a good thing too. Okay, next slide, please. We do have a supernova. It's in the sky. It's NGC 4666. The galaxy itself is about 13th magnitude, and the supernova at discovery was 12.3, but it has gotten a little brighter. I have not seen it yet, but it is truly a telescopic, if not a photographic supernova. Next slide, just show you where it is. If you take Spica, which is a very prominent star in the semi-morning sky, and it's just up here. So those adventurous enough to get up early in the morning to photograph it, we'll see pictures next month, right? Right. Next slide, please. And there it is. Well, of the planets, then we get to see pretty well all the visible planets that we have in our solar system over the course of the night. First of all, on the 16th, just after sunset, we have brilliant Venus, which is up in the sky now. Who has seen Venus in the western sky? It is coming up there now. So on the nice triage here, we have Venus along with Mercury, pretty close, and then Mars will be up here. So that'll be a nice digital moment on the 16th. Next slide, please. Of course, Jupiter is in Leo, close to Leo, so very prominent throughout the night too. And Saturn is just rising over here in the eastern sky. And here's Spike again where the supernova is. Okay, next slide. So, as mentioned before, with the 4 Galilean moons orbiting around the planet, sometimes we do get some very nice transits and shadows that come across Jupiter. Well, actually on the morning of the 24th, we actually have 3 shadows, a triple transit, which is pretty rare. And in fact, even this month too, if you check the Observer's Handbook, we even have satellites occulting each other or eclipsing each other. It's just a right tilt of Jupiter to allow this. So it doesn't happen all year round, but twice a year it does. So now we have 3 Galilean moons coming across. Be very dramatic. So I'm not sure if that's during the week or not, but it's pretty rare to see 3 nice little black ink spots. Next slide, please. I'm at 25 seconds now, I guess. Good. Just the monthly of your favorite. Of course, our favorite is new moon, and it's the snow moon. Huh? No kidding. Snow moon. That's in the Farmer's Almanac. I didn't make them up. It's just like a harvest moon, hundreds of moons, such a thing. Okay, next slide, please. And of course, I do have my monthly article that's on the national website, The Sky This Month, and I'll be speaking about Orion the Hunter, which is very prominent in the sky. If you haven't seen Orion, sorry. It's so bright. It's pretty well, if you hold your hand up like a stop, that's the size of Orion at arm's length. So it's a very bright, prominent constellation. Okay, next slide, please. And speaking about the 3 stars in the belt, which are about 800 to 1,000 light years away. Speaking about the Flame Nebula, and of course some of the other galaxies that are in Orion. Galaxies are usually springtime. We don't associate galaxies too often with winter skies, but they're all over the place. So if you want to read it. Next slide, please. And that's it for this month. Thanks, folks. Take care. That's it. I'm going home.
Yes, right. Did you even park your car, Gary? Okay, next up is, thanks, Gary. Next up is Rick Wagner. He's going to talk about polar alignment techniques and what he's learned over the years. So Rick, I know you're here.
that a door prize, sir?
No. If you can pry it from my cold, dead hands. Okay, polar alignment. Mike asked me to do this a couple of months ago, and my first question was, why? He said, well, okay, there's a number of beginners who have issues with polar alignment. It can be a difficult subject. I find a lot of the stuff that you find on the web, the instructions and stuff, there are little features about it that are kind of confusing. But more importantly, why are we polar alignment? If we have the, polar alignment is the solution. What's the problem? Why do we want to do this? I have control?
Yep.
There we are. Okay, so if you're a star hopper, as I am, as you look around the sky, for instance, with a Dobsonian, north is in a different direction. Everywhere you look, your telescope moves left, right, up, down, not north, south, east, west. Plus, it's an astronomical telescope, so everything's inverted. So here I've got M101. So suppose I found it in the field. Now I'm trying to star hop off to these little galaxies. Well, how do I orient this star chart so that I can actually figure out which direction to start moving my telescope? Oh, that came out dimmer than I thought. I tried to dim it down so it looks fairly realistic, maybe too realistic. There's M101. So now I'm looking through my telescope and I can see there's a little smudge over there. And of course, being a good amateur astronomer, I'm making notes in my notebook. And I want to say that little smudge is about 20 arc minutes north. No, that's north. No, I'm in an inverting eyepiece, so that's west. No, I don't know. It's a pain. And this is what you get in a Dobsonian. The problem I have too is that sometimes if I'm working, I put my mount or my telescope on a Ponce table. So now it's actually driven to follow the sky. So I can't even see which direction the stars are drifting in the field of view to try and figure out what the orientation is. So that can get really difficult. Of course, the big problem is that the stars are moving. You can see they roll slowly across the sky. Well, I say slowly. If you're looking at Jupiter at 600 power, it screams across the field of view, and you're busy trying to, I missed that, trying to jiggle it back to where it belongs. So those are the big problems. Not the problem. Well, of course, if you've got a Dobsonian telescope, you're not going to polar align. You live with it the way it is. A lot of the go-to scopes now, a lot of them are actually Altaz mounted. You can put them on a wedge to make them polar aligned, but you don't have to. And you can do this quick star alignment thing that you pointed at a few stars and tell it where you're pointing and stuff, and then magically it does all the calculations, and it actually does the conversions for you. It will actually do the tracking. It still has the problem, of course, that you can't actually do imaging off of it because, as you appreciate, if you watch Orion, it rises tilted one way, then it's standing upright, and then it's tilted the other way. So if you try to actually take a picture with your camera mounted on an Altaz telescope, you'll get rotation of the field, and it won't work. So what do we need? Well, we need, obviously, an equatorially mounted telescope. They have two axes. One goes east-west. We're going to imagine that the North Pole is up there. So one of them we go east-west. Uh-oh, I pushed something. There. The other one, north-south. Fairly easy. The other thing they have, and it's important to make a distinction between the two, and a lot of people don't make this very clear, is that they also have adjustments under here to move the mount up and down, not the telescope. So there's times when you want to move the telescope for observing, but the rest of the time you want to move the mount to align it. And I think the other thing they do on the web a lot is they show the telescope like this. And I remember when I was a real beginner, I kept looking at this. I gotta put this down before I do something. And trying to figure out, how do you point this over there? I mean, at the time, I was looking in magazines and stuff, and it wasn't clear. And the obvious implication here, if we're polar aligning the telescopes, well, obviously the telescope needs to point at the pole. And I actually saw a guy online who said, well, now that I've got it polar aligned, how do I look at stuff? Because if I move the telescope, it won't be polar aligned. Well, no, it's the mount that needs to be polar aligned. So, okay, well, there's our German equatorial mount with its polar axis in blue pointing north. I'm going to be very hemisphericist today. We're not going to talk about the southern hemisphere. It's all going to be relative to the North Pole and stuff. And then there's our declination axis, where we go north-south. And a fork, I know a lot of you have telescopes like this. The polar axis goes up between the forks. The declination axis connects the top of the two forks. So we get in a little closer. You can start to see some of the detail in the insides here. These are the knobs that actually adjust the mount. You can see these knobs adjust it in azimuth. This knob adjusts it in altitude, adjusting the mount. The other thing they have, and it's kind of dark here, but most of the mounts will have a scale somewhere on that you can set your latitude on. For a lot of uses, that's a very handy thing. So one of the first things you do when you get one of these is adjust it until it's pointing to your latitude. So polar alignment is the solution. Basically, we're trying to get the axis of the telescope parallel to the axis of the Earth. I was at the Kingston Center meeting last night, and the way one of the physicists in the crowd described it was, what we were trying to do is we were trying to put the telescope in the rotational frame of reference of the stars, not the rotational frame of reference of the Earth. In other words, on the Earth, we're spinning around. We want to try and make our telescope so that as the Earth spins, the telescope remains fixed in the same direction. We can track the stars with only one axis. This was the big advantage that they always said in the old days. If you look at the old ATM books, you have to have a polar mount because then you only have to move it in one axis to follow the stars. Consistent field orientation in the eyepiece. You can give the telescope a little nudge. Now you know where north is. Boom, another little nudge. Now you know where west is. It doesn't matter if you've got an inverting eyepiece, a star diagonal that corrects the image or doesn't. It all becomes clear. And the scope always moves north, south, east, west. So, for instance, if you want to star hop somewhere, you can say, I need to go so far north and then so far west. You can do that easily. However, there are different degrees of solutions, different methods of the solutions, depending on what your individual problem is. For instance, sky axis. Can you see the pole from where you're observing? Can you see the east and west horizons from where you're observing? That has an effect. If you're going to do it visually, or are you using a camera? It can make a big difference. So, there we are. There's the Earth with its axis of rotation and my massive telescope sitting out there in the Pacific Ocean, but with its polar axis exactly parallel to the axis of the Earth. So, what kind of accuracy do we need? Well, it depends on what you're doing. If you're just doing casual viewing, which I suspect for most of the beginners, that's where you are. Basically, you're finding and tracking objects. If you want to use the go-to on your scope, it should be reasonably well polar aligned if you're going equatorial. If you're doing imaging, short focal length, like piggyback stuff, long focal length, if you want to get into extreme focal lengths, if you're doing planetary work. Are you auto-guiding? Do you have a second camera that's actually making corrections to the motion of the mount? One thing you have to be aware of is precession. The Earth's axis of rotation is actually wobbling around the sky with a 26,000 year period. So it's actually, if you offset from Polaris, every year it's a slightly different distance from Polaris. And a lot of the, some of the alignment techniques don't take that into account. So this one's for Brian. This is for casual observing, point and kick alignment. Basically, for visual astronomy, star hopping, this will give you everything you need. I set the latitude scale on the telescope. I go out. I sort of stand behind it and I go, oh, there's Polaris. We're done. And that will give you good enough tracking that you can follow an object, even at relatively high power, for several minutes at a stretch. Your go-tos, if you're using go-to, it probably wouldn't work very well. But if you're star hopping, that's all that's really required. The other thing you can do is you can actually refine it, get a decent compass, and some sort of an angle gauge that you can actually mount or just hold against the mount, and you can actually do a reasonably good daytime alignment. We used that some years ago. Shoemaker-Levy 9 impacted Jupiter. Well, it was doing it when Jupiter was setting very soon after sunset. And so in order to see the impact sites, we actually had to get the telescopes aligned and on target before the sunset. So the next step up is the polar alignment scope. Now generally these are included inside the mount of the telescope, as you see on this one. But it doesn't have to be. And in fact, for the fork mounts, mostly it doesn't. It does need the pole to be visible from where you're observing. Doesn't require a camera, so that's a nice feature. So here's where you start with one that's not built into the telescope. What I've got here, this is actually called a barn door tracker, and it's got a hinge along one side, and this top board just pivots up and drives your camera to follow the stars. And what I have is basically just a small, cheap rifle scope carefully aligned to that hinge, and then I can adjust that to point to the pole. How do I know where the pole is? Well, I put a star chart on the face of my barn door tracker. So there's the handle of the Little Dipper. There's Polaris. And the next star, there's a little star that's just visible in my polar alignment scope, and then the pole is that little cross right there. So this is about 1.5 degrees. So you can figure I can pretty carefully get that aligned to probably 1/4 degree, maybe better. And that will allow me to do 10-minute exposures, with like a 100mm lens. Is all you'd ever need to do with a digital camera. The ultimate polar, in my wildest dreams, this is the telescope that I keep on the patio outside my villa, my mountainside villa overlooking the Mediterranean in Liguria. And I keep it there for when I go over for the weekend and I need to observe. Basically, in this case, and this is one of those confusing pictures where they've got the telescope perfectly aligned with the polar axis for some reason. Well, in this case, it's actually useful. If you set it up that way, you can get a not bad alignment. For instance, especially if you set your setting circles to Polaris, then you just aim the telescope at Polaris, and you're pretty well polar aligned. So that's quite easy. However, this is the kind of thing I have. There's a little telescope inside the polar axis. This cap comes off, and there's a cap down here, and they expose the eyepiece at the bottom end. See, it's got a little wire here, so it has an illuminated reticle in it, so I can look through. And then the cap on the other end, I don't know if you can see it, but inside there's actually, this is the declination axis, so there's actually a hole through the middle of the declination axis so that you can see the pole through the little telescope. So inside the little telescope, there's what's called a little reticle, a little piece of glass with etched lines on it to show you how to aim this thing. This is out of an EQ6. At least at one point, these things do change occasionally. Basically, what they show is the Big Dipper and Cassiopeia. Now, you can't see those in the telescope. So what you have to do is you have to kind of stand back and you say, well, there's where Cassiopeia is, there's the Big Dipper. So you adjust, you rotate this little telescope until those constellations are in roughly the same alignment as they are in the sky. And then you put Polaris in that little circle, and you're polar aligned. The one problem with this one is that you notice this little circle is a fixed distance from the pole. And so over time, not very quickly, but over a period of years, that's going to become less and less accurate. This is the Losmandy, if you have a G11 or a Titan 200 or whatever. This is their reticle. Wow. Again, it includes the constellations, so you can get a rough alignment. It also has stuff for the southern hemisphere, just to keep it confusing. But once you get the alignment roughly done by standing back, looking at the constellations, what you do is you put Polaris in this gap, and then there are two little stars that will fit in this gap, one of these gaps and one of these gaps. And you can see these are actually labeled by date. And so by picking a year that's close to the current year and putting your little two stars in the right positions, it corrects for the precession. So you actually can get quite an accurate polar alignment, providing the reticle is actually properly aligned, which mine is not. When I put up my telescope on a pier and stuff, I did it all beautifully, and it was off by quite a bit. So I had to use other techniques. This is the reticle in this little telescope. This is really nice. It's very simple and clean. There's actually two circles, one for the southern hemisphere, one for the northern hemisphere. The hand controller has a little application in it. You say, I want to do a polar alignment, and it comes up and it tells you, put the star at X distance at such and such a time on the clock, right? 12. So it looks like a little clock. And you just adjust the mount until Polaris is in the right position and you're done. And this one I've tested. It is actually very accurate. So the next thing, well, there's an app for that. New technique. If you start slewing your telescope around the sky, if it's not aligned properly, every time you move it and point it at a star, it's going to point incorrectly. So that's a problem. A lot of the software now, Doug George makes one called Max Point. There's the T-Point. Some of the mounts actually have a package built in called Polar Alignment Correction or whatever. But basically the idea is, at its most complicated, you take a whole bunch of pictures across the sky, so the software ideally will actually slew the thing, take pictures, solves them, figures out where each one is pointed, and then it does a mathematical model of your mount. If there's errors in the gears, if they're not round, if the axes aren't perpendicular to each other, all kinds of stuff like that. And then it reports back. Well, in fact, what it does is it corrects for all those errors when it's trying to point at the stars. Well, obviously, though, it knows what all those errors are, and so it will actually report how far off your polar alignment is. So make a correction. The better packages will actually tell you to point at a star and then tell you how far to move the star, so you can actually watch in images as you move it. So you make a correction, you go back, start over again, probably have to do another smaller correction, and then you're probably good. What's nice about it is you don't have to be able to see the pole. You can have a fairly restricted area of sky, and it will work. In theory, you can do it with an eyepiece. It will say point to this such. It will slew the telescope to such and such a star. Then you adjust the pointing until the star is centered. You say, okay, that's the star. It will go to another star. You center the star. You say, that's it. And you keep doing this several times. It would be a lot of work. I wouldn't want to try that for anything less than a permanently mounted scope. Drift alignment. Ooh, this is the nasty one. This is the one that everybody gets confused. It's supposed to be the technique. It sucks. Basically, it's somewhat similar to the mount modeling in that if there's an error, the stars, your telescope isn't going to track the stars properly. And so if it isn't, if we measure how much it's not tracking them properly, then theoretically we should be able to work back and make corrections to the pointing. You don't have to be able to see the pole star, which is nice, but you do need to have access fairly close to the east or west horizon. You can do it with an eyepiece or a camera. So, what do we have? Basically, here's a view done in starry night, and we're looking south across my lake, and there's the meridian, so that's basically due south. And the red line is the top one. That's the true, the blue one, the lower one, is the true equator. That's the actual equator on the sky. However, my mount is tilted a little far back. So my mount thinks the equator is a little higher. Well, if I'm looking south, you can see that a star that's drifting along here and my telescope driving along there, the two are almost exactly parallel. So I'm not going to see much drift of the sky. But if I look down here, you can see that the two paths are crossing. They're coming to a point. So in other words, as I'm watching, the star will be making one motion, my telescope will be making the other, and because I'm driving, what I will actually see is the star will actually be drifting in the field of view, always north or south. So what I need to do is I point my telescope off to the east or the west, look at a star near the equator, and watch it for a few minutes and see how fast it drifts, north or south. And then I can make a correction. If, on the other hand, my telescope, instead of being leaning back, is now shifted left or right, what happens is the true equator is one line, the telescope thinks it's over to the right. And so you can see down where I was looking down at the horizon, the two lines are roughly parallel. But to the south, they're now crossing each other. So again, as I watch a star going across the meridian, it will appear to drift north or south in the field of view. So again, I can make a correction. So here's the procedure. Loop, 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 loop. What you do is you measure the star, the drift of a star near the east or west horizon. You adjust the altitude of your telescope. Then you measure it again, make another adjustment. Measure it again, make another adjustment, until it doesn't drift anymore. You've finished the first loop. Second loop, go to the equator near the meridian. Watch for a drift, make a correction. Watch for a drift again, make another correction. After 3 or 4 times, the star's not drifting anymore. But the trouble is, there's crosstalk between these two. So by making this correction, you've now damaged that correction somewhat. So you start all over again. Go off to the east horizon or west horizon, then do the equator again. Then you go back to the east or west horizon, then you go do the equator again. Now you're pretty good, but you want to get a little finer, so now you have to measure the drift over a longer period of time, 5 or 10 minutes. Make a correction. Watch it another 5 or 10 minutes, make another correction. Loop, 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 loop. It's nuts.
Morning time.
But there's an app. There's an app, and several apps, in fact, that will help you do it. And I think, I've never been able to use them, but I think they will make the process at least feasible. The trouble is they do require a camera. You can't do that with just your eyepiece. There's also another technique done by some robotic observatory guys back in the late 80s, which is somewhat similar to drift alignment, but it's actually even more complicated. But it can be automated fully. And so if anybody's interested in that, they can talk to me afterwards. Now, we come to the pièce de résistance, the Boltwood technique. Paul Boltwood is an Ottawa Centre member. He developed this years ago. You have to be able to see the pole, and you have to have a camera. But other than that, this is the perfect way. Aim your scope parallel to the polar axis. So that's what I've got here, is the telescope is parallel to my polar axis. Take an image while rotating the telescope. So what I do is I put my telescope like this. I start a picture. Over about 60 seconds, I do that. Okay? Sometimes You know, if my telescope is pointed off, it's going to miss where the center of the circle. So you might have to do some adjustment until you get it parallel. The other problem you can have is sometimes, like on my homemade telescopes, the telescope is actually tilted. It's not perpendicular to this axis, and then it doesn't hit the pole. So I have to shim the telescope until it works. But that's a one-time thing. So we've done our exposure like that. We lock the mount. Okay. Now, what do we get? Okay, so there's the scope parallel to the polar axis. This is what your picture will look like. Here's the arc of the stars. That's actually Polaris. And it's kind of dark here, but you can see there are other stars arcing around. Now, the important thing to realize is that the center of these arcs is exactly where the polar axis is pointing. Not necessarily where the pole is, but exactly where the polar axis is pointing. So, I need to find out where's the exact center of those arcs. Well, I use a tool in Maxim, but you can use any piece of software. Basically, if I draw a perfectly horizontal line across one of those arcs, I know that the center of that circle must lie exactly on the midpoint of that line. I can do the same thing over here with the side of the arc. So I find that the center, my telescope is, or my polar axis is actually pointing at that pixel, 705 across, 957 down. So that's where my the pole is pointing in my picture. Now I lock the telescope. I don't tiddle with the telescope itself anymore. Here's a picture that I took shortly later. This is the actual pole. It doesn't really have a nice little cross to mark it. I put that on there. But it does have a nice little star pattern that you can recognize. This is actually a crop from one of my images. But basically I can see, you know, from these stars, I can figure out pretty darn close where the pole is. So what I have to do now, I found the X and Y center of the arcs. Now I move the mount, not the telescope, until the true pole is at the point where the center of the arcs were. So I do that by adjusting the mount up and down, left and right. So what I'm doing is shifting where the pole is pointing on the sky until it's pointing at the true pole. And so the way I do that is I just set the camera to take 10-second exposures continuously, and I make a little adjustment, and I go, oh, went the wrong way. Make a little adjustment, oh, now I'm going in the right direction. A little adjustment, a little further, and you can see as I do each adjustment, the stars drift a little bit while I'm doing the alignment or the adjustment, and I just keep doing that until I've got, here's my star pattern of the stars near the pole, and that's where the real pole is, and that's pixel 705, 957, and so you can see that they're awfully close together. The distance is actually 12.2 pixels, or 45 arc seconds, so that's less, that's like 100th of a degree. That took me 10 minutes. So if you can see the pole, I mean, and this, I quit at that point, right? Because I'm doing a demonstration. I have a temporarily mounted scope out in the parking area behind my house. If I was going to be doing this with an observatory mounted telescope, I could get that down to a pixel or two. So we're talking arc second errors. So we can do the alignment. There's a bunch of different ways. A few points about it. Do we need this kind of precision? If you're doing long exposures, yes, you want this kind of precision. But most people don't do long exposures anymore, right? You do 3-minute exposures, 5-minute exposures. You might do 15-minute exposures. This kind of stuff is a holdover from the days of film. where you might sit on a galaxy and expose for 2 hours continuously because you only get one piece of film. You can't stack images. So it's nice to have it like this when you take an image, even if you're auto-guiding, right? Your auto-guiding does a lot less work. There's a lot fewer corrections. So I think it's worth doing this if you're permanently mounted. And in fact, to do it to this accuracy takes, like I say, 5 or 10 minutes using this technique. So it's worth doing. So I think that's it. Any questions? Everybody's completely baffled. Yeah? Okay. Question?
Hi.
Hi.
This is gonna probably sound really dumb. What you know how that kind of telescope has the mounts? What if we have a really simple telescope that's just on a tripod?
Well, this could be mounted on a tripod, but you mean if it's not equatorially mounted, like
You know,
a little
we just have
fort?
there's more simpler telescopes that are just the barrel. They don't have the particular
Yeah.
parts.
Well, that's basically an altazimuth telescope,
Yeah.
and it doesn't do polar alignment.
Okay.
So-
So there's not much you can do about that.
No.
Make it better?
No. But they work fine. I mean, you know, you have to be a little more careful about orienting your charts and stuff. You know, you're going to be star hopping anyway. That's the important thing is to know is, and maybe I didn't emphasize it enough at the beginning too, is that even if you're using an equatorial telescope, if you're doing visual work, most of the people who are beginners are going to be doing visual work. You don't have to have a whole lot of accuracy. Point and kick, you know, get you within a degree or two is quite adequate, at least for starting. Yes?
I was wondering when these equatorial mounts were first invented. I know they're at least 100 and maybe
Yeah, they're, I don't know, but yeah, they're over 100 years old, certainly, a couple of 100 years.
Rick,
Yeah.
to the podium.
Oh, sorry. I can't see anybody from there. Any other questions? Yeah.
Leveling the scope, how important is that to have it level?
In theory, it's not important at all, but in practice, it, like mine, it actually has underneath here, there's actually a little, one of the centering bubble levels, and by going out in my parking area, and I stick boards under the feet until it's level, adjust the little screws on the feet and stuff, and I get it really level. And my polar alignments are always, you know, I mean, it's, you know, I might have to go a degree or two east-west or left-right, but up and down, they're always, it's almost always near perfect. So it makes it easier. In fact, if you're doing point and kick, then, you know, yeah, you should be reasonably level. But again, you know, just for point and kick stuff, just look at the ground you're looking, you know, if the ground is obviously sloped, then you're going to have to deal with it. But
If the azimuth adjustment has a latitude scale, you'll need to be level to use that correctly.
yes, that's right. Yeah, the latitude scale is dependent upon the mount being level. Anybody else do polar alignments? Richard?
What about if you're dead on the equator?
Well, then basically, this whole thing just rotates until it's flat, so that the polar axis points at the northern horizon. And correspondingly, if you're at the pole, you would tilt it this way so that the polar axis would be pointing vertically. And if you're doing that, then you can just use an altazimuth telescope, right? Because its azimuth axis points straight up anyway.
Because when I polar align, I always have to keep adjusting my latitude. So that means something is shifting on the ground because my latitude keeps going off.
Yes, well, and that's the thing, you see, is if you kept the mount level, right, then your latitude scale should come out right once you're polar aligned. But if your mount is off level, right, then you're going to have to adjust it. Right, and then of course it will be reading the wrong latitude.
Yeah, of course. Okay.
Yes.
You have a tracking system for your barn door setup, or? How do you track and keep stars aligned with that?
Basically, I polar align, and then there's an old-fashioned synchronous motor driving a little nut that we should do a talk on barn door trackers. It has a motor, yeah. And again, they're
Do mine by hand.
yeah, and that's a viable way, and I used to do that. I started off with one where you put a watch on the board,
Oh, yeah.
and then I had a handle, and this is the way I read somewhere how to do it. And you turn the handle at the same rate as the second hand on the watch, and that works quite well. I came up with the idea: take the whole mount, rotate it 180 degrees, put the watch on top of the knob, and turn the knob backwards, and you actually keep the second hand pointing in the same direction. Much easier to do, much easier to keep it accurate, but your polar alignment's not going to be very accurate. The screw is not going to be desperately accurate. My better barn door tracker actually uses a curved bolt, which is much more precise. We can get into the details of different types of barn door trackers and stuff. The big reason I put a motor on mine was because I found I go out, and I started with this in the days of film, so I would go out and I would do a 10-minute exposure. And meanwhile, there are meteors and comets, and and I go home and what did you do? Oh, I spent 2.5 hours looking at my watch. Not. So, the limitation, of course, is with a motor, I need power. So.
Yeah.
Anything else? All right. I think he's going to kick me off. All right. Thank you.
Thank you, Rick. Well, thanks everyone, and thank you, Rick. I enjoyed that interaction. I'd like to do more of these. I'm not sure I would call that beginner talk. He talked about some things that are a little bit beyond. But if you have any suggestions on these kinds of topics, let me know. This actually idea came out of a suggestion that came to me from someone. A couple of things here I want to mention before we go to break. As usual, what I like to talk about is membership benefits. Of course, we're going to talk about the Fred Lossing Observatory and a little bit later on with Gordon Webster. We do have a telescope loan library and a traditional astronomy book library. A telescope loan library is a Ted Bean library. We have that on the web. So if you actually Google that, you'll see pictures of most of the scopes that we have on the web. And if you're interested in signing out a telescope, we actually do have Al Scott. He's our telescope loan librarian. And he's here tonight too. And I know we've had quite a number of them that were on loan. And by the way, just before I forget, if anyone would like a little bit of maybe hands-on help with polar alignment or some of the things that Rick talked about, and can't wait till our summer star parties next, or I guess summer. Some of you know, maybe we can. I'm sure I can find somebody that lives near you, and we can arrange something. Okay. Next slide, please. So a couple of things here, Chris, bring it up. So some of the other benefits are you can see on the screen here. Subscription to Sky News comes with the magazine. Canada's Astronomy magazine comes with the membership, and
What just happened?
okay, I'll speak to it while we restore the. I'll give this to you in case something. Something new. I don't know if you, some of you who are subscribed to the RAC national list, noticed that there was as part of the bulletin that comes out, is that if you've what's the sort of default with your membership is a electronic version of the RAC journal, and so I don't know how many of you actually go and read it online, but. There's an option to, I think it's an additional $20 we just confirmed to pay for a paper edition. Well, in the month of February, the national office is going to be sending actually everyone, a member, a paper version. Okay, and I guess actually the intent there is to just to maybe if you haven't been reading that and you're interested in the paper version, well, you can try it out again for free, and you can pay the extra $20. I'm a bit of a paper person myself, so that's something that's coming up. I'm trying to remember the other thing as well, Chris.
Observer Handbook.
Oh yes. The other announcement that came out was the Observer Handbook, which you all get as members. It's actually available now in electronic version. So if you want to put that handbook on your computer, I see there's a $10 charge for that as well. Okay. Before we go to break here, just the last couple of things. RASC calendars. Al, do we have any left, or do we sell them all?
Yes, some.
Okay, I think there's probably only about 5 to 10 calendars left. One for 16, two for 30. We'll have them outside. And we will also have the raffle tickets for the few door prizes we have. So, Al, where's that? Right behind me? Okay, that's why. So come pick up a raffle ticket, and we'll make the draw after the meeting. Folks, we'll figure out what's going on here, and let's have our break. Lights, please. All right, our next talk is on the Fred Lossing Observatory, our center's observatory. Gordon Webster is our center president, and he's a frequent user of Flow, and he's going to talk about what Flow has to offer. So, Gordon.
Good evening, everyone, and Happy New Year. So the more time I spend observing at dark sites, the more I realize just how blinded I am in my Orleans backyard by the intense light pollution from nearby Park and Ride shopping center, on-ramp to the Queensway, and just the city in general. I find that I'm looking more and more for a darker site to observe from, but driving for 2 hours in each direction isn't something I want to do regularly either. And in the winter, being somewhere other than the backyard usually means that the only place to get warm is the car, and I haven't figured out how to turn the lights off when I open the door, so you lose your dark adaptation. And year-round, I'm a coffee drinker, and there are issues there. One of the benefits of being a member to the Ottawa Centre is that there's a solution to this in CFLO. When it was first built, the observatory was located in North Mountain, but for a variety of reasons it was moved to its present location in the 90s, where it became known as the Indian River Observatory because of its location near that river. On Saturday, October 24th, 1998, after his death in May, when he could no longer protest, it was renamed the Fred Lossing Observatory in his honor. Born in 1915, Frederick P. Lawson grew up in Norwich, Ontario. He attended the University of Western Ontario, and he received his PhD in chemistry from McGill in 1942. He spent most of his career working with the NRC, National Research Council here in Ottawa, excuse me, where he published somewhere around 170 papers, which have since been cited in well over 400 subsequent publications. He first appears in the RASC Ottawa records in 1952, when at an annual meeting he played cello in a string quartet. Is that something we could get, Mike? String quartet?
Absolutely.
Yeah? Okay, good. He was a founding member of the Ottawa Observing Group. He built over a dozen of his own telescopes, and 2 of them were prize winners at Stellafane down in Vermont. They also awarded a 3rd prize, which was awarded to the team project that actually built the 16-inch telescope that's at the FLO. During his time there with the group, he illuminized virtually every amateur mirror in the Ottawa area. He helped people build their own scopes. He designed a drive system and an inexpensive photometer, both of which were widely used by other amateurs across North America. But it was his work on the North Mountain Observatory for which he received the RASC Service Award in 1973. At the time it was built, the 16-inch was one of the largest amateur scopes in North America, and Fred and others used it to do real science, including discovering the breakup of Comet West, the change in period of the dwarf Cepheid variable, CY Aquarii, and the slow change in brightness in quasar QJ287, another of those catchy names. Fred was a guiding force with the Ottawa Centre in the 70s and 80s. He was vice president and president from 75 through 78. And as mentioned, he was heavily involved in the construction of the 16-inch telescope that's in the observatory. He also built the related buildings, which were originally built on the site in North Mountain. It was also Fred who negotiated the release of those buildings from the OPP when they were caught moving them without a permit between North Mountain and where they currently are. Slide 2, please. Fred Lossing Observatory is located just off Highway 29 on a back lot, of the Milliken Tail between Almont and Pakenham, about 25 minutes from Canada. And yeah, you can see that, whoop, what did I do? Okay. Which one's the laser?
Top one.
Top one. Okay. So you can see it circled there. And this is Highway 29, Blinny's Corners Road. Okay. The observing site is set well back from the road in a good-sized clearing in the woods. Because of this, of course, you don't get views of the horizon in any direction. Slide 4, please. But the photo, sorry, next slide. Okay. That's the gate to the observatory. And so I guess the next one, please. There we go. Okay, so the photo gives you a good indication of the average tree height surrounding the site. They're a little taller to the northeast, which is over here. The surrounding trees, I find, are just high enough to hide most of the light domes from Ottawa, Carleton Place. And they're low enough that they don't really block a significant portion of the sky. Thanks to the continuing efforts of Pat Brown and others, the surrounding municipality actually has an active light abatement policy in place to help preserve the skies. Ron St. Martin, is the director of the FLO, and he takes care of all the things on the ground, including making sure the grass is cut and the snow is plowed. The access road is kept well cleared in the winter, and it's maintained year-round. One of the original buildings is now a warm room. That would be this one. And of course, the other one houses the 16-inch there. Yeah, and so to use the 16-inch, you have to be checked out on its operation, and Ron does training courses for those who are interested. And the observatory has a roll-off roof. I'm not sure how well it shows up, but you can see there are beams back here, and this just slides back there. At the end of the access road is a large open area, which is here. And the observatory buildings are to the east. There's an observing mound to the south of the observatory, up here. As well, there are observing areas just sort of out here and over here. When you're setting up, if you're using it, please use either the mound or the north-south sides of the parking lot. Don't set up in the middle of the parking lot. Ron will hunt you down. But what about the sky? Clear sky chart shows that it's an olive green, but what does that really mean? The first thing you'll notice, I guess we can go to the next slide too. The first thing you'll notice is that the Milky Way is clearly visible. This is just a shot at dusk. You can see a few stars coming up. Milky Way, sorry, M31 is a naked eye object, and the fainter Messiers that are invisible in my 12-inch scope in the city are easy in my 120 millimeter at the FLO. So that's losing track of my slides here. Okay, so next slide, please. So here's a photo that I took just piggybacking on my refractor. It's a 2-minute exposure at ISO 3200. For comparison, next slide, please. This is an image taken of my Orleans.
Should we kill the lights so we can see the screen better?
Yeah, we better. Just for a sec, because I don't think it's showing the difference here. That's it. Yeah, it's that. Actually, on my, yeah, you can see it there. Okay, so the second one, that's a 13-second exposure in Orleans. So you can see there's quite a difference. Okay, I need the lights back. Thanks. Okay, we can go to slide number 8, I guess, please. Next slide. As you may recall from last month's meeting, Mike Worth has generously donated his 18-inch Starmaster to be used at the FLO. In addition to that, we've got a 14-inch Celestron Smith Cassegrain. There's a 10-inch Dob and a 13-inch Dob as well. And this is the 16-inch. Council will be meeting actually later this month to figure out what to do with all these telescopes and actually get them functioning. I had word a couple of days ago that the Mill of Kintail has actually okayed us putting up a couple of new observatory buildings. So we can actually put up separate observatories for each of the scopes. And with any luck, we'll get them operational before the end of the year.
Well,
The good news, yeah, I said that already. So how do you get to use this wonderful observing site? It's open to all members. You're welcome to use the grounds at any time. All you need is the combination lock on the gate and an explanation of the configuration of the other locks, because there's 3 or 4 locks on it, and there's a certain way you have to open it so that you don't lock the other users out. If you want to use the warm room and or the telescope, the 16-inch, then you need to take Ron's training course, okay, so that you understand the operation of the roll-off roof, the telescope, and that is all controlled from inside the warm room. So after that, you get a key. The porta potty is not locked. The FLO, I guess slide 2 again, please, just so people can see where it is if they don't already know. That's the map one. There we go. Okay. I like the FLO. I go there quite often. Sometimes I go alone, sometimes with friends, and very often when I arrive, there are other people there. Just as often I have the place to myself. It's not Nirvana, but it's close. It has a warm room and it has a porta potty. I can go observing for 4 hours and still get enough sleep in my own bed to make it through the next day at work. And that's a nice combination. Thank you. Yeah. Any questions on anything?
Yeah. You were saying you're hoping to put a few more buildings up?
We're not sure quite how we're going to handle it, but that's sort of the direction we're thinking we're going.
How do you fund that?
Well, that has to be discussed, but we do have some reserve funds. So, yeah. Yep.
I've never been to the Observatory, but I would like to go. Are there driving directions you can give us? I mean, I see the map, but I'm still not quite sure.
Yeah, I can give them to you now. Okay. Basically, you get to Highway 29.
Yeah.
Okay. And you head from Almont towards Pakenham, or you're coming the other way, doesn't really matter. Now what you're looking for is...
I'm going along the Mill of Kintail. I passed the Mill of Kintail.
It's actually on the grounds of the Mill of Kintail. Okay? So if you're coming from Almont towards Pakenham, okay, you will see a sign that says Mill of Kintail, turn here. Okay? That's not the one you want. It's the next one. Okay? You're going up the back side. And that would be the Blinny's... Where'd it go?
Benny's Corners.
Sorry?
Benny's Corners.
Benny's Corners, that would be this intersection here. And so you just come up and it's on just past the curve. Before
The address is 365 Benny's Corner Road.
There you go. And if we can go back, I don't know if it shows on the gate, but on the gate, or right by the gate, there's a little sign that says FLO, a little reflective sign. Yep. Okay? And if you want to go, I'm always looking for somebody to go with. And my wife doesn't object as much if I'm going with somebody. So call me and we'll go. Okay? Anybody else?
Yeah, Edward?
Yes,
Point of clarification, fees are not free, there's a yearly fee for each.
that's right, yeah,
$35 for the year.
Yeah.
After your training course.
exactly. Yes,
Yeah, just a comment, there are power outlets on the outside of the observatory building.
okay.
So if you want to just go there, take your scope and set it up, there's power if you need it.
Yeah, good point.
Hello?
Yes?
Yeah. With regard to, is there, it's a 2 or 3 part question here. Is there a lot of competition for the use of, and what is the etiquette for scheduling the use of the observatory?
There is a user group, a Yahoo user group, where people do go on and post that they're going out on such and such a time and planning to do some observing, and that would sort of reserve it for you. The demand isn't as high as you might think.
So if you wind up with, as you say, you go out and there's someone else there, what's the common etiquette to share?
In my experience, people have been very open to sharing it.
Okay.
Okay. Occasionally, you'll get somebody who's doing some photographic stuff, and you know they've got a list of things they're trying to catch. But in my experience, it's never been an issue.
Okay.
But as I say, there is when you take the course and whatnot, then you get access to the user group, and if you want to post that you're going, that's pretty much going to reserve it for you.
Thank you.
Okay. Yes.
Have we ever had a star party?
Not that I'm aware of, but it's something that has been suggested, and I think we should consider for the summer.
What was the question?
Have there ever been any star parties held at the FLO? Yes. How is it heat? Well, it's electric. There's electricity run to the building, and there are electric space heaters inside. So when you first arrive, it's going to be a little cool, but it warms up quite nicely. Yes.
So the setup area isn't in the center there, it's off to the side, right?
It's more off to the side, yeah. I mean, the preferred location is right here on this mound.
That's right past the gate, isn't it?
No, that's the gate.
No.
Oh, the gate's behind.
The gate's behind you. It's in. I've been trying to figure out how far in from the road it is. I've never really measured it, but it's got to be. Sorry?
Quarter mile.
Yeah, I was going to say about half a kilometer or so. Yeah. So it's well back from the road, and then the road opens into this field, which that's showing about a quarter of it. Okay. So there's a good size area.
Another question up here.
Yeah.
Just long ago, there used to be trouble with ground fog, and that's one of the reasons for extending the hill, the mound on which the telescope is located. Is ground fog still a problem in the summer now that we've got all those trees around?
I haven't experienced any. And in my discussions with Ron, he's never mentioned it. Yeah.
What fraction of the people that you go out and you see there actually bring their own scopes and don't use the 16?
I would say probably most of them. It's more, people are more inclined to use it as a good observing site than use the 16-inch. There are, at last count, I think there were 35 key holders. So basically, those are the only people that have access to the either the warm room or the 16-inch.
You can't get in unless you have a key,
Exactly.
even to the gate.
No, you have access to the grounds, but not to the buildings.
Or you can get into the grounds without a key.
Yes, you can. Yeah, there is a combination that you need.
Just one question to the group. How many people would be interested in a group tour? I mean, instead of having 1 or 2 people, just raise your hands here. Okay. So I'm seeing at
great.
least
Yeah.
15, maybe 20, 15 people, 20. Okay, tell you what. If you don't mind, come after this meeting, sign your name, and give me your email address. We'll organize.
Yep,
we'll
we'll
organize
something.
Let's do that,
Yeah.
folks. We got to end the questions. Great
Yep,
discussion.
okay.
And thanks for doing that,
Okay,
Gordon.
thank you.
Okay, next up is Tony Peterson sharing his a year in review from some of his finest. So Tony,
Well, it's not my finest. It's stuff in 2014.
you want to let us know.
Well, if it'll help a little bit, I don't know. It would help me, but I don't know if it'll help anybody else. Doesn't really much matter. So I'm told January is a time for retrospection, so I thought I'd take advantage of that situation to put up a few of my images on the big screen here that I hadn't showed from 2014, one from each season. And am I going to get this right here? So oh boy, that's pretty dim. Okay, I should have brightened all these up for this presentation, but anyhow, in the winter, I finished a 2-year project on M1, the Crab Nebula, photographing with narrowband filters and making an image with the Hubble palette, which uses, as we can see, S2 for red, hydrogen alpha for green, and oxygen for blue. My filter is a 7 nanometer bandwidth, so it's also going to contain nitrogen with the hydrogen. Now, of course, well, this is all with my 6-inch telescope from my backyard. And of course, mostly in the winter, because that's when we see M1 up in the sky. M1, of course, is a supernova remnant. It was the first one actually to be recognized. It's an historical N1054 supernova, 6,500 light years away. Its angular width is, I think, about 7 minutes, and it's about 5.5 light years across in real units. Okay, so one could spend a lot of time talking about this. I'll just quickly note, we used different colors for the filters. It didn't come out monochromatic. Of course, the elements are irregularly distributed. And I'm not talking about, oops, sorry. I'm not talking about, go back. There we go. I'm not talking about the sheets and filaments. I'm talking about the larger scale variations. So hydrogen concentrated up here, blue down here, and sulfur seems to be mainly in the middle. That is not a result of mass fractionation from the expansion of this object. Those are actually irregularities in composition that were generated in just a few minutes during the supernova event and frozen in. They didn't have time to homogenize at all. So you can see the same thing in iron and so on, but of course I have no way of imaging that. In the spring, this is a picture of light pollution with the Milky Way behind it. From the Madawaska Highlands, I was testing my new 14 millimeter lens on an old Canon XSI, may it rest in pieces. The shutter broke. This site is usually much darker than what you see here. All this light pollution from the urban blight to the south was thrown up into the sky by poor transparency that evening. So maybe we'll call this a teaser. Hopefully I'll be able to get this lens out under much better conditions this summer. In fact, I'm hoping I can do it from the southern Alberta, where if you point south, it really, really is dark. That was the spring shot. In the summer, at the end of summer, yeah, geez, I'm sorry, this isn't coming through all that well. Galaxies in Pegasus, again, that 6-inch telescope. Unusually for me, I completed this image in one night. All my equipment, including my own brain, was working perfectly, and so I was able to image straight through from dusk until dawn. But no luminance, just the color filters. If you look down in the lower left-hand corner, this was a bucket list object for me, Stephan's Quintet, which consists of some gravitationally interacting galaxies. Well, not quite, because actually the larger blue one here is a foreground galaxy. It's much closer, 39 million light years. I'd imagine it's a plus and minus in that, to 280 million light years for Stephan's Quintet. And I don't think that you can see it. But there is a tidal stream, just barely, you can make it out, emanating from here, curving around towards this small galaxy up there. That is part of the interacting set. And it all comes with the very creative and romantic name of a Hickson compact group, number 92. This large infalling velocity, 500 kilometers per second, refers to the relative velocities of this galaxy here and this one. The region in between there has generated an enormous shock wave. It's a very bright X-ray source. And if the screen was bright, you could see that there is, in fact, a very slight increase in visible light right where that shock wave is, but we're not going to see that on this screen tonight, unfortunately. And in the top right corner, a completely accidental group of galaxies, the Deerlich Galaxy Group. That does not refer to something an ungulate did to someone's telescope. The Deerlich is an observing site in the southeastern states. So the large foreground galaxy here, NGC 7331, is about the same size and luminosity of the Milky Way. And these other smaller galaxies in the background are about 10 times as far away. And right at the beginning of fall, another bucket list object. NGC 891 in Andromeda, again the 6-inch telescope. This one was over 2 nights. I acquired quite a bit of luminance data on the second night when seeing conditions were really excellent. Eric LeMay was out with me for both those nights, and he'll attest to the beauty of this night. I think that's about all I wanted to say. In the top left corner, okay, just barely visible there. Oh, there's another interacting pair of galaxies, and I just point this out because this is a personal best for me for distance, known distance to an object, 560 million light years. I'm sure there are many faint fuzzies in this image which are much further away, but I don't know how far away they are. So this is, like I said, a personal best. I'm going to see if I can break that every year. And now that thing's so close, it's not even worth talking about, eh? Who cares? Okay. In the bottom right corner, and we'll be able to just see some of these, are a couple of dwarf satellite galaxies of NGC 891. UGC 1807 is 1.6 arc minutes across, and it's big enough to show quite a bit of internal detail. I would encourage everyone to go to my website and see these images as they should on a good computer screen. There's one, just a tiny little smudge, which I don't think we can see here at all. It has no designation that I'm familiar with, and that's the other satellite galaxy that's visible in this image. NGC 891 has 5 other satellite galaxies, but they are all outside the field of view of this image. Oops, that's the wrong button. Okay, so this galaxy is surely on everybody's short list of their favorite galaxies. It's in the Milky Way's local group, quite nearby, again of similar size and luminosity to the Milky Way. Whatever imager tries to get out of this object are these tendrils of dark, cold gas that are extending vertically away from the plane in either direction. The jury is out on one of 2 hypotheses of how those formed. Either they're blasted out by supernovae or simply by light pressure from very active star-generating regions. And I think I was going to stop there, Mike, on this.
Keep going.
Keep going? Okay, we have time. All right, bonus picture. This is actually from 2013. This is my largest mosaic. It's a 3x3, so it's a 9-panel hydrogen alpha image with an 85 millimeter refractor. 50 hours acquisition time. This took me 2 years. So we'll just look at some pieces of it. In the top right corner, the Crescent Nebula. It's 26 light years wide. It's not really, it's not classified as a planetary nebula, although it formed kind of similarly. Apparently, there's a shell of gas that was blown off by a red giant, which then contracted and is powered by a Wolf-Rayet star. But the hydrogen alpha emission is not stimulated as it usually is by ultraviolet radiation from the central star. Instead, there is an extremely strong stellar wind, a plasma wind coming away from the Wolf-Rayet star, which blew out and formed a shock wave. And apparently the shock wave also bounced back, and so astrophysicists can see that it's moving in 2 directions. But that is what is stimulating the radiation. At 5,000 light years away, this nebula is actually slightly behind a lot of this faint nebulosity that we see here. And you can see in this particularly bright region here, there's some obscuration of this Crescent Nebula. Just to the left of the bright central star, which of course is Saturn, that's Gamma Cygni, there is a relatively young open cluster. I don't know exactly how old it is, but this nebula complex is spawning a lot of these as we speak. Saturn is very much a foreground star, only 1,000 light years away, 1,800 light years away. If I recall correctly, it has about 12 times solar mass and 150 times our sun's diameter. And finally, the Gamma Cygni Nebula itself. It's known to some as the Butterfly Nebula. I'd be careful with that. That's a very popular name. Lots of things in the sky are called Butterfly Nebula. And there's Saturn again. And that's all I had to say.
All right. Anybody want to see Tony again this year? Thanks, man. Thanks, Tony. Okay, let's do the next observer reports. If Janet, Gary, Gordon, and Paul could come up to the front. Janet first, please. Right one.
Tony's a tough act to follow, but especially when you see my humble little contribution. There we go. This image was just an experiment to see if I could reach prime focus when my DSLR camera was attached directly to my Celestron C8 telescope. And it turned out that I couldn't. So what you're actually looking at is a combination of barrels that were jimmy-rigged by my friend Paul Kay over there to my 36 millimeter Hyperion eyepiece, and we were determined to get focus in minus 17 degree weather, and what we came up with was this, and it's not perfect focus, but it's not bad either. And I was just reading in an article in Sky News that, in fact, the moon only reflects something like 12% of light from the sun, which is about the equivalent of asphalt. So, not bad. Thanks.
Thank you, Janet. Next is Gary.
First. Yeah, again, they're really going to have to brighten up this this projector because the slides should be a lot brighter than this. This is my attempt at a comet Lovejoy. Actually, it was 25-second exposures on a tripod, 1600, to stack together. So I just couldn't believe the actual color. I didn't get any kind of tail or anything, obviously, with that short kind of exposure, but just to show you the green. In binoculars, it's not really that green, but photography really brings out the colors. And next slide. Well, after about 3 weeks of cloudy skies, we had the grandkids over. Of course, they don't sleep past 6 a.m. And this was 6:45, and I just happened to look outside, and just this beautiful digital moment over here, a nice crescent moon. In fact, there's a star right here that's just coming out of occultation. Chi, I forget the constellation. It's about 900 light years away. But just a very picturesque moment. And my granddaughter's only 4 years old, and she says, the moon looks different. So even she knows at 4 years old. That's great. And that's my 2 slides for this month. Thanks.
Thank you, Gary. Yep. Gordon. And Julia, I bet. Oh, you bring your dad, Julia?
Hi again. Okay, in November I showed 2 sketches lunar sketches that I said were unfinished, and I promised to show you the finished versions. This appears to be Kepler, and do we have the next one? No, really? Okay.
Before and after?
How does it look from there? Right, from here it doesn't look much better, but a little bit. I should have brought the originals to show you. Anyway. It's a lot, the original's a lot darker. It's a lot more contrast. Can we try the next one? Okay, that's the before. And that's the after. It's showing a little better. So anyway, I'll bring the sketches next month if anybody wants to look at them. Okay, next please. We have a photograph. NGC 281, the Pac-Man Nebula. It's objects like this that got me started in trying to play with astrophotography, because people keep telling me these objects are out there, but I can never see them. And so I figured with the camera, maybe I'll be able to prove to myself they really are there. This is a stack of a whopping 2 photographs with 180-second exposures for a total of about 6 minutes. That's done with the Canon T3i on a 6-inch Newtonian. Next, please. Okay, so this is NGC 7814. It's a magnitude 11.6 spiral galaxy in Pegasus, and it's sometimes called the Little Sombrero because of its resemblance to 104. And this sketch was done at the FLO just before Christmas using my 12-inch Daub. And next, please. And this is M78. Can you see the nebulosity there? Yeah? Okay. This one was a surprise because I got this from in my backyard in Orleans, and this is the first time, with about 5 different telescopes, that I've actually been able to see this object from Orleans. And this was done with my brand new, not a Christmas present, 6-inch refractor. And it's fun. I like it a lot. And then this next object, okay, that was it. That was my sketch. Done with colored pencil. No, what's next? We should have a sketch. Me and you. Oh, okay, we're going to do it together?
Do you have another one?
Well, no, just the sketch. I was just going to do the lead into it. So the next object is Hoag's object, which Paul showed you last month. I first heard about the object from Sue French's column back in the spring of 2012. And it's a rare ring galaxy. At the time of its discovery, there were only 2 known galaxies like that. And the other one is at the 1 o'clock position within the ring. You can just see it up there. Those are the only 2. They've got about 40 or 50 of them now. So Paul and I were observing out at the Burnt Lands near Almont on the May long weekend that year, and we decided to try for it. So we were using my 12-inch Daub, and we used the RA and deck coordinates and moved the scope to that. And it's a 16th magnitude object.
Go to your sketch.
So, yeah, can we go to the sketch?
Which is
one more.
This one.
One more. There we go. Can you see it in the sketch? Anyway, it's a 16th magnitude object. We were using an 8mm Hyperion eyepiece, which gives us a 22 arc-minute field of view. And we were actually able to spot it. It's literally on the edge of perception, but it was definitely there.
We wanted to share this with you because, as some of you may know, I was talking about the previous image, which was just flashed up, and it was Gordon that turned me on to this object here. So we talked after last month's meeting and thought, well, we should show our combined observations from our original work back in 2012. So yeah, this is why we put the sketches up side by side, or the images up side by side. Gordon's on the left there. Again, this projector, and I apologize for this because the projector is just, I think we should take up a collection and buy them a new bulb or something. But you can see there's a really nice correlation here. I'll just oh, sorry, I'll be here.
That's okay. That's all right.
Yeah.
Oh,
I can put this into the...
So
Ghostbusters.
We got this pattern here. We got these 2 bright ones, 2 of the 3 bright ones up there, and the bright one down here.
And I know Gordon's like Gordon's ring is right pretty much in the same position. There's really really hard to see with this projector there. But it was really cool when we compared them side by side. The correlation was just really very neat to see.
Paul, why don't you come right up here?
Oh, okay.
Is it showing it all from up top?
I can see it, but just barely.
We should move on, guys.
That's what
Yeah.
it was like in this film.
And you guys did this independently of one another, right?
No, we were out in the Burnt Lands on the same night.
Okay.
Yeah. Well, and the reason we want to show this again is because it was such a thrill to see this thing, because it's a ring galaxy that's 600 million light years away, and we could see it with our naked eye. Which is really cool. So we've supplied coordinates. Again, the information up at the top is barely perceptible, but you can certainly Google this object. For those of you that do have scopes, Gordon had his 12.5-inch Dobsonian out, or 12-inch Dobsonian, and at 187 power, we could actually see this thing. Now, to give you an idea of how big it was, for those of you that may have looked at Mars in the last opposition last year, is about the same size as Mars. It's only about 17 arc seconds in diameter, so it's quite small. You need good conditions. Somewhere out at FLO, where we were observing, isn't far from FLO. Yeah, you need definitely good conditions, a nice stable sky. But just the fact that you can see this thing and realize how far away it is, it's pretty cool. Best seen from about the beginning of April to about the middle of July. So if you want to give it a try, yeah, it's well worth seeing. But yeah, Google it. You can get the coordinates and you can find finder charts for it. So thanks, Gordon.
No, thank you.
So I'll just take over from Gordon from there because I've got a few of the last ones there. Thanks, Gordon. I've just got a few things for you. I wanted to provide you a bit of an update on SmartScope. Jim Maxwell and Wolf Luncher and I were out last month. We were doing our final tweaks and pokes, and we're getting pretty close there. So you can see I took a couple of images, so one of the moon there. Detail's good, all the stuff is working, nothing's broken right now, touch wood. We'll see what happens, and hopefully it's a lot of exciting talk about new telescopes at FLO, and with SmartScope getting close to where it should be, I think this could be a very exciting year for us. So I shot that one, and then we shot a deep sky object. That's into the heart of the Orion Nebula, and you can see the trapezium right at the center there. So this was also shot with that on the same night, so that very almost full moon was up at the same time and only about 20 degrees away from M42. So yeah, we were pretty pleased with the work there. So yeah, we're keeping our fingers crossed, and we'll keep you abreast of further details with SmartScope. Next, please. So current events. Venus and Mercury, really nice conjunction. I saw it tonight very briefly. Check it out. It's not often you see these two guys nice and close together like that, and they're only about a degree apart, which is only about twice the diameter of the full moon. But your observing window for this is very narrow, because if you're too early, the sky is too bright and you won't see Mercury. You'll see Venus easily enough, but you won't see Mercury. And once the sky does get dark enough, the pair sets very quickly. So you have about 20 minutes of optimum viewing time. And that's, right now, that's from about 5:15 to about 5:30, 5:35. So if you want to check it out, a really pretty pairing. They're very close together. I shot this 2 nights ago. When we had, sorry Janet, got you beat, it was minus 26. Yeah, that was that delightful night. Plus the wind was howling. It was, yeah, a bit of frostbite on the fingers there, but interesting to see anyway. All right, next please. All right, I have managed to see Comet Lovejoy. You must get out and see this thing. It is naked eye easily now, especially if you're in a dark site from the city. You'll easily get it with binoculars. I saw it again 2 nights ago, and that'll be my next image. But this one I shot on December the 30th. Again, this was just after the moon set. I had to wait until the moon went down. The comet was only about 6 degrees above the horizon. Still managed to put on a pretty good show, and you can see some of the tail there. But 2 nights ago, after I warmed up trying to image the Mercury-Venus conjunction, had about an hour's long window from about 6:30 to 7:30. And so the next one, if you would please. Wow. So it's out there and it's very visible. So thank you. Just to give you an idea too, both those comet images were shot with an Ioptron SkyTracker platform and DSLR with a 200 millimeter telephoto lens. It was just way too freaking cold to set up a telescope. So, and,
what ISO?
And I shot at maximum ISO because I knew the exposures would be short. So ISO 6400. Only this is a stack of 4 30-second exposures. So it's very brief. But if you take a 50 millimeter lens and even put that on a tripod, you'll bag it, and the tail is long enough, it's worth it even with a 50 millimeter lens. Then you don't need a tracking platform or anything else. Just crank up your ISO and shoot for 10 or 15 seconds. See what you get. See what you get. And but definitely check it out. As Gary mentioned, it was actually on this night 2 nights ago that it was closest to the Earth. It's now moving farther away from the Earth, but it's actually expected to get brighter in the next week or so because it is nearing the sun. So its best show could still be on the way, and we've also now entered the dark window. So The best time to see this thing is from about 6:30 to about 10 o'clock right now. And so if we do get some clear skies, they are calling for clear skies for next Wednesday, Thursday. Definitely check it out. It's one of the best comets that we've seen in a while. Thank you very much.
Okay, we're going to get ready to close the meeting here. Club information, if you wish to contact any one of these members about various aspects, you can Google or you can just go to tinyurl.com, RASC Ottawa, as you see. Next slide, please. Estelle's pick of the month. Estelle normally picks she's our book librarian, astronomy book librarian. The library is still at the Science and Technology Museum, so but it's coming to the Aviation Museum hopefully soon. There's an after meeting social event at Perkins Restaurant, which is Ogilvie, and I keep forgetting Salarois Road. It's open to all. You don't need to be a member, and you're certainly welcome to join us. As you know, we are recording this meeting here. It's broadcasted live on the internet, and it's also posted on the internet as well. Erica, on YouTube now? How long does YouTube? Okay. How long does it take to get to YouTube?
About 2 weeks.
About 2 weeks? Okay. Well, what I'll do is I'll send out a note again, or either myself or Eric will send out a note when it's available, and you can watch it again.
But you can watch it right now after the meeting on the Ustream website that we're webcasting on. It's recorded there. I just do some refinements later for YouTube, little fixes here and there.
Okay, great. So you can just go to that website right now, right after the meeting, and you can watch it.
That's correct.
Okay. I don't know. We have quite a few people here tonight, and more than I expected for 92 for a January meeting. That's awesome. Thanks to all the speakers and folks that prepared their presentation. Next meeting is in February 6th, the same location. The agenda is we have two speakers again. It's Carmen on historical figures in astronomy. Remember, she presented about 6 months ago, right after she retired, and I managed to get her again. And then, of course, Ryan Anderson. You see him about once every year or two. Ryan works at Telsat, and he's a pretty prominent role in Telsat satellite design. He's going to talk about some of the emerging satellite technologies. So I think that'll be an interesting presentation as well. That's it. We're going to close the meeting.
Without Chris tonight, we would have had no pictures at all on the screen. He had his own projector used tonight.
Yeah,
Thank you, Chris.
we had some real formidable hurdles here.